Hi there. So we're going to keep talking about things that have proportional relationships, which is where we're going to jump to sectors here. Now, the homework is going to be from a worksheet. You can print it out if you like, but also you can just do all the homework right in your homework notebook, just like it is from a textbook. Don't forget to nominate any questions that you have from yesterday's assignment if you're stuck on any of them, and I will review the videos and post explanations for those as those votes come in. So get yourself ready for notes, open to the page on sectors, and we're going to get started. So the first thing I want to do is define what a sector is. We have a nice picture right here. This yellow part here is a sector, as is this part here, if I wanted to, or even a semicircle. A sector is just a pie slice or a pizza slice. So what that means is that it is a part of a circle. So part of circle that comes from the center. So created by two radii, so coming from the center, and radii is the plural for radius. It's a nice second declension masculine word for those of you who are interested in Latin. And then the arc between them on the outside of the circle. So if I'm looking at this picture here, the yellow sector would be formed by this radius px, this radius py, and then the arc between them is this arc right here. Now, in number 1, it asks find the arc length and the area of the sector. So arc length would be the distance xy here. So as I said, this is the arc. And sometimes that's just abbreviated with an L for length. And as I said, these are proportional. So if I look at the arc length, the proportion between that length and the circumference, which is 2 pi r, right? This is your circumference of the circle. So you can think about like the entire circle as a full arc, is equal to, and the other proportion would be 360 is the full circle in the denominator, and this is theta. This is a symbol for angle. And one thing you'll notice as you get farther along in math is that the symbols for angles tend to be Greek letters, while the symbols for numbers, the variables for numbers, are Latin, Roman, English letters. So this is the angle of the sector. It's sometimes called the central angle because it's in the center of the circle. And this letter is called theta. And again, it's just a variable. So if I'm looking at the picture here, theta, the angle is 45 degrees. And 8 then would be the radius. Now, area works really similarly. The area of the sector, it's going to be the same idea. It's a proportion for the angle over 360, and that's because the entire circle is 360 degrees. If you look here, it's 180 down here. Then these two are supplementary, so that would also be 180. So 360 for the full circle. And then we're interested in area out of the area of the full circle, which is pi r squared. So in each case, the numerator is the sector amount, and the denominator is the full circle, and the proportions stay the same. Now, if we're asked to find the arc length and area of the sector, I can just use these formula with the numbers plugged in. The first thing I'm going to do is find arc length. So we have L. Sorry about that. You've got L over 2 pi times the radius 8 is equal to the angle 45 over 360. Now the nice thing about a lot of the problems you're going to run into in sectors is that this proportion tends to be easily simplifiable. And in this case, 45 over 360 is 1/8 of the circle. So then the arc length is L over 16 pi is equal to 1/8. So when we cross multiply, the numbers are a lot more straightforward. This becomes 8L is equal to 16 pi times 1, which is just 16 pi. Divide by 8 on both sides. So the arc length by itself is equal to 16 pi over 8, which is 2 pi. Nice thing about leaving in terms of pi, we can just leave it like that. Now, for the area, we'll use the other area. Pi r squared is equal to, again, 45 over 360, because the proportion stays the same. It's a sector. So in this case, I am just going to automatically 45 over 360, we said is 1/8, and r is equal to 8. So we end up with a over 64 pi is equal to 1 over 8. Cross multiply. And 8a is equal to 64 pi. Divide both sides by 8. And 8a is equal to 8 pi. There's no unit in the setup, so we don't need any unit in our final answers. Now, sometimes, just like what we've seen in the past in other lessons, here it says find the area of the sector. And what we have here is we're given 12, which is the radius. And we're given 8 pi centimeters, which is the arc length, because it's on the outside. It's that curved section. So what we can do here is we could plug arc length into the arc length formula, back solve for theta, because what we're missing here is we don't know how much of the circle is there, right? Now, what we can do, and what I would recommend that you do, is we can recognize, as I've said, these two are the same proportion. Arc length and area both have this proportional relationship. So what I would do is I would say, well, since arc length over 2 pi r is equal to theta over 360, which is also equal to area over pi r squared, we don't necessarily always need to use that middle proportion, and we can say arc length over 2 pi r is equal to area over pi r squared. So if you don't have the angle, you can use this proportion. And since we don't know what the angle is, I'm not going to back solve and find it, though you could, it would just take longer. I'm going to immediately jump to my arc length, which is 8 pi over 2 pi r, which is 12, is equal to area, which is the thing I want to find, over pi r squared. And as I said, r is 12. Now from there, I want to simplify. So I get 8 pi over 24 pi is equal to a over pi r squared, so that's 144 pi. Simplify here. Divide both sides by pi, divide both by 8. So I get 1/3 is equal to a over 144 pi. Divide both sides. Well, here I'm going to cross multiply. And I get 3a is equal to 144 pi. Divide both sides by 3. And I end up with a is equal to, and I would simplify it like this. If I didn't have a calculator, I would say, well, I know this is 12 times 12 pi over 3. And I can simplify one of those 12s by 3, which cancels out to 4. So this just becomes what is 12 times 4, which I can do easily from my times tables. And that's how I get 48 with pi tacked on. Now here we do have units, which are centimeters. So it's area, so it must be centimeters squared. Like so. So that's how you can do it if you don't have theta, but you're given a different quantity. If you have any questions about sectors, If you're stuck on anything from the homework, please nominate it in the form. If you want to ask me specific questions, you can leave it in the comments, email, or set up a Zoom.